Okay, so our goal when we're solving an equation is to get the variable by itself. In the opener, we had A, B, C, D, E, and F were our variables, so we circled that variable, and that's what we were trying to get by itself. So the goal is to get the variable by itself. Go ahead and write that down. Next thing on your note sheet says golden rule, and it even starts the golden rule for you. Whatever you do to one side of the equation, finish that sentence for me. You've got to do to the other. So the golden rule, and I'll refer to it as the golden rule fairly often, whatever you do to one side of the equation, or whatever you do on one side of the equation, you must do on the other side. This is the most important thing when we're solving equations. This is a pretty easy rule to follow when we're doing one-step equations. And even two-step equations, this will be pretty easy. But later on, we'll be doing equations where we have variables, two different variables on the same side of the equation. Or we might have to do the distributive property and combine like terms first. And when we start doing all that other stuff, this is a really important rule to follow. And this is where it's really important that we have that line of equality. And whatever we do on one side of the line, we do on the other. And we'll talk more about this as we get to it, but we're going to run into some equations where it's going to be easy to forget that rule sometimes. The last rule that we're going to use for solving equations, if you need to get rid of something on one side of the equation, what do you have to do? What operation are you going to use? So for example, if you want to get rid of a plus 3, what do you do to get rid of it? You subtract 3, right? So you're going to do what operation? Opposite or inverse. And you can put either thing there. Either one of those would work. I'm going to put inverse in here. But opposite operation would be okay too. So the opposite operations, what's the opposite of adding? What's the opposite of multiplying? What's the opposite of a square root? Close. Which exponent? Square. So the opposite of a square root is a square. We're actually going to solve some equations that have square roots in them. And you're going to have to remember that the opposite of a square root is a square. Or the opposite of a square is the square root. Okay, it works both ways, right? Any questions about these? You guys remember these, right? So let's look at some examples. They're going to get a little more complicated, like I said. So, I don't know. Should be example number 1. This is example number 1. Sorry about that. Write the equation down and then don't do anything else yet. We'll kind of talk through this one together. So what's my goal here? If I want to solve this equation, what's my goal? To get the variable by itself. That's our goal every time we're solving an equation, right? Since we want to get the variable by itself, I'm going to identify that variable by doing what? Circling it. Okay, that circling the A is just a reminder that that's what I need to get by itself. My rule is, whatever I do on one side of the equation, I have to do on the other. And my reminder for that rule is what?
Line through.
Draw the line through the equal sign. Okay? Now, the difference between this problem and the problems we've been doing is what? There's two things that I have to get rid of. Okay, and all the ones that we did in the opener, all the ones we did first triad, and the ones we did in the opener yesterday, we only had to get rid of one thing and the variable was by itself. Now we have to get rid of two. So we have to get rid of them one at a time. I can't get rid of the 3 and the 8 at the same time, but I have to do them one at a time. Anybody want to guess which one we're going to get rid of first? The 8? Okay, you guys agree with Keishan? 8? I agree. We do need to get rid of the 8 first. So how do we get rid of that 8? Subtract it. Just like the other equations we've been solving, we're going to do the opposite. So the opposite of plus 8 is minus 8. Now, if I do it on the left side of the green line, I have to do the same thing on the right. Pretty straightforward. Here's the difference, though. Now, when the 8's cancel, I don't have the variable by itself. What do I have left on the left side? 3a. And on the right side, we have 14 minus 8, which is 6. So we have this equation now, 3a equals 6. We still have to get rid of the 3. And how do we get rid of that 3, Nate? We're going to divide by 3. And when we do that, the 3's are going to cancel. And what's left on the left side when those 3's cancel? A. And how about on the right side?
2.
Put our equal sign on the line. And we're done. It's not too bad, is it? It's going to be a pretty tough class for you then, Claire. All right.
When they come down, just a quick question. When they come down to the...
I want to get what by itself here? I want to get the b by itself, so I'll circle that. And I want to remind myself that whatever I do on one side of the equal sign, I'm going to do on the other, so I'm going to draw that line there. So again, we have two things we have to get rid of. We have to get rid of the 3, and we have to get rid of the minus 4. Anyone want to guess which one we need to get rid of first? The 4? What do you think, Nate? Okay, Nate's suggesting that maybe we use the distributive property, and we could actually do that on this problem, but we don't need to. Good thinking. That would actually work. If we use the distributive property, then we could use that to then we could use what we get from that to solve this equation. So we either need to get rid of the 3 first or the minus 4 first. Let me ask you this. You guys remember order of operations? PEMDAS. Please excuse my dear Aunt Sally. We do parentheses, exponents, multiply, divide, add, and subtract in that order. For this, we're going to use order of operations backwards. So we want to get the b by itself. If you pretend like there was something in here with the b, or if we put a number in here with the b, then we would do whatever that is. Let's say there's a 17 there. We would do 17 minus 4 first, because our order operation says that we do what's in the parentheses first, and then we would multiply by 3. Well, if we want to get the b by itself, we have to work backwards. We can't start with the stuff we would do first, but we have to start with the stuff we would have done last. So when we do the order of operations here, what would we do last? What would we do second? We would multiply by 3 last. So to get rid of that 3, we're going to divide by 3. So we're going to divide by 3 over here. Let me change that real quick. We're going to divide that whole thing by 3. Yep. Hold on. We're going to solve the equation, and then we'll get an answer. And if we divide by 3 on the left side, we have to divide by 3 on the right side. That's our golden rule, right? Well, the 3's are going to cancel on the left. And so when the 3's are gone, what do we have left over there? B minus 4. Now, that would be in parentheses, except we don't need the parentheses anymore, do we? So we can get rid of those. So that's going to be b minus 4 on the left side is equal to, what's 21 divided by 3? 7. And then it should be pretty easy from here, right? We still want to get the b by itself. If you feel comfortable or if you feel like it'll help you, go ahead and circle the variable again. You don't have to, though. At this point, it's pretty easy to see what we're trying to get by itself. What'd you say, Lucas? Add 4 to cancel out the 4 there. Add 4 there. And, yep, 4's are going to cancel. What's left on the left side? B. And on the right side, we have 7 plus 4, which is 11. Cool? Questions? All right, let's do a couple more here. Now this one should say example 3. must have just flipped those, sorry. Okay, so we want to get the c by itself. I know you're writing the equation down, but I'm going to go another step ahead of you here. So I have two things to get rid of. I have a 3 and a 7 to get rid of. If we're doing the opposite of the order of operations, what would we do first? If we had a number in there for C, would we add 7 first, or would we divide by 3 first?
I'd say divide by 3 first.
If we had a number in there, so like let's say that this said I don't know 5. That's not a good example. Let's say it was 7 plus 7 divided by 3. Would we do the 7 plus 7 first, or would we do 7 divided by 3 first? We would do the plus 7 first, right? So that's what we're going to save for last when we're trying to get the c by itself. Does that make sense? We're going to go backwards. Since we would do it first with the order of operations, we're going to save that for last right now. So we need to get rid of that 3 first. How do we get rid of the 3? All right, that is divided by 3, so the opposite of that is going to be times 3. Multiply by 3 on both sides, and the 3's are going to cancel, leaving what on the left side? C plus 7. And on the right side, 12. Don't forget to copy down both sides. One of the biggest mistakes that leads to errors, that leads to getting the question wrong, is getting the 12 over here on this side, but not writing the c plus 7 over here. And some people just put 12 as their answer. Some people might forget what's over here and do the wrong thing and get something completely different. So be sure that you're writing down everything that's left over there. All right, what next? Okay, yeah, we need to get rid of that plus 7. The opposite of that would be minus 7. 7's cancel, so we get c by itself. And 5 on the right side. Okay, let's do one more then. So we have d over 4 minus 7 equals negative 2. What are we going to try to get by itself here? All right, so we have two things we need to get rid of so that the d can get by itself. That would be the 4 and the 7, right? We need to get rid of those. What should I get rid of first? The 7? You guys agree with that? I agree with the 7. If we were doing order of operations here, the first thing I would do is d divided by 4, and then I would subtract 7. So since the minus 7 is the last thing I would do, that's the first thing I have to get rid of. So to get rid of the minus 7, what do I do?
Plus.
Add 7. And on the left side, those 7's are going to cancel, and what's left over there? D divided by 4 equals negative 2 plus 7 is... Okay? Then what? I still have to get the d by itself. Got to get rid of that 4 by multiplying. So multiply by 4 on both sides. 4's cancel on the left. What's left over there? And on the right? Any questions about that? So flip it over real quick. We're not going to do those last examples today. We'll do a few more examples tomorrow to practice. Actually, not tomorrow, but later. But I do want you to fill this in. And these notes you'll be allowed to use on your homework or quizzes or whatever. When you're solving equations with multiple steps, with more than one step, you want to use order of operations backwards. So you're going to use the order of operations, but you're going to use it backwards to get the variable by itself. So this is just another example here that I put up there so I can explain what we're doing. Like I said, we're not going to do any more examples today. But if I want to get the g by itself here, if I want to get that by itself, if I were doing order of operations, I would do g divided by 2 first, and then I would add the 3. So if I did the order of operations backwards, I would get rid of the 3 first, and then get rid of the 2. Does that make sense? Okay.